Hello dear students, I Abhinav Sir welcome you all in your own platform that is Resultant. In this session guys, a very important topic of soil mechanics, your geotechnical engineering part, that is quicksand condition. That I'll be telling you what is quicksand condition, what is its significance, why it is not quick clay, why it is only quicksand. Okay, each and everything concepts derivation I will be doing in this video. I hope you are doing fantastic guys, and let us begin our class. Those who are new for the first time in this channel, let me introduce myself. My name is Abhinav Sir. I have done my MTech from IIT Delhi, got all India rank 164 in 2012, and I have done my MTech in Geotech, the same topic I am teaching you right now. Everyone on the comment box guys, how is the Josh? Please let me know. Everyone. Okay. Guys, you can join me my Telegram group Civil by Abhinav Sir. Already more than 6,200 students have joined here. Okay. And guys, the biggest of the announcement on 7th and 8th September. That is Saturday and Sunday. Saturday and Sunday. Today and tomorrow. If you want to join Resultant, guys, you can give the scholarship test. The scholarship test consists of only 20 questions. You will be getting 45 minutes and 20 questions, 5 from SOM, 5 from maths, 5 from FM, 5 from aptitude. Total 20 questions. And if you perform well guys, if your rank is all India rank first, second, third, you will be getting 90% discount, 4 to 10 rank 80% discount, 11 to 50 rank 60% discount, 51 to 75 50% discount on all our upcoming courses. So guys, the link is given in the description box of this video. The link is given in every Telegram group of Resultant, and link I will be providing later on also. Okay, after this video. Everyone please guys, on the comment section, how is the Josh? If you want to get the scholarship on all our courses guys, all our courses, then you can give this scholarship test. How to get the scholarship test, either the link of the test is given in Telegram groups or description of this video, or you can download the Resultant Civil app from the Play Store, and after downloading the app you can give the scholarship test there. It is of free cost. Now guys, tomorrow, that is Sunday, 8 p.m, one more faculty, one more challenging star will be coming to the Resultant platform. And again guys, that star, that faculty will be from Byju's only. So our complete team, the current team of Byju's has already shifted here. Okay, now the old teams, the old faculties of civil are also joining Resultant. So he is BTech from IIT Kanpur, all India rank 49 in GATE. BTech from IIT Kanpur, having a huge experience. He will be joining Resultant, and you will be getting this tomorrow at 8 p.m. on this channel only. You can connect me. These are our numbers also guys. Now guys, what is this? How suddenly this picture comes? Guys, this is quicksand condition. Now in this picture, whatever is happening now, that condition is quicksand condition. When this is quicksand condition, this is quicksand condition, when the soil has almost zero strength, it cannot resist the load. When it cannot resist the load, this is called a quicksand condition guys. It is not able to resist the load. Okay, now how this quicksand condition arrives? What are the reasons for this? Why it is not quick clay? What is the derivation? Each and everything I'll be telling you from zero level in this session. Okay, shall we start? Shall we start it? Okay. Now guys, you can ask your doubts in between. Suppose guys, this is a soil mass. Okay, this is a soil mass. Here it is soil. Now let me assume this is soil here. In this box it is soil, it is filled with water. Now suppose here this is datum. Okay. Now suppose this is 1 point. Okay. This is 2 point. This is 3 point. This is point number 4. I'm just naming the points. This is point number 5 and this is point number 6. I'm just naming the points. I'll play with these points now. I will play with all these points now. Guys, I'm telling you from zero level, each and everything you will be understanding. Now, this is 1, 2, 3, 4, 5, 6. Okay. Now, I will be writing the energies of these points. Okay. At all these points, I will be writing the energies. Okay. Let me copy paste it here. Let me copy paste it here. Okay. So, these are 6 points. What will be happening? Seepage will be happening. Water will be moving from here to there. Why water will be moving? That everything will be seen here. Don't worry about that. Now, guys, these are 1, 2, 3, 4, 5, 6 points. This is point number 1, 1, 2, 3, 4, 5, 6. At these 6 points, I will be writing the energies. What are the energies in soil? There is velocity head. Okay. There is pressure head. There is datum head. 3 types of energies in soil: velocity head, pressure head, and datum head. Okay. How to write all this? I'll be telling you. Don't worry. Don't worry, guys. Let me make it little smaller. Let me make it little smaller. Here. Velocity head will be even. I want to add, insert row or column to the right. Okay. So velocity head, pressure head, data. Thoda sa go little there. Go little there. Okay. Velocity head, pressure head, and datum head. Okay. 1, 2, 3, 1, 2, 3, 4. Let me delete all this. I'll make again from 0. I'll make again from 0. Don't worry, don't worry, don't worry. I'll make everything from 0. Okay. Everything you will be getting. See, suppose this is the datum. Datum means with respect to this, I will be measuring the height. With respect to this, I will be measuring the height. What are our points? Our points are, this point I am saying as 1, this point I am saying as 2, this point I am saying as 3, this point I am saying as 4, this point I am saying as 5, and this point I am saying as 6. What will happen? Everything I will be telling from 0 level. Just see, each and everything I will be connecting now. Each and everything I'll be connecting soon, within next 2 to 3 minutes. 1, 2, 3, 4, 5, 6. These are 6 points. I've written 6 points. Now guys, in soil, the total energies are velocity head, pressure head, datum head, and then summation of all. Summation of all is equal to total head. Total energy. High energy we represent in terms of height. In all water related subjects, fluid mechanics, hydrology, OCF, energy we don't write kilonewton or joule or anything. We write energies in terms of height. Velocity head, pressure head, datum head, and summation of all will be total head. Okay. Now velocity head is easiest of all. Just close your eyes. At all these points, there are 3 types of energy: velocity, datum head means potential energy, pressure head and velocity head means kinetic energy. Velocity head means kinetic energy, datum head means potential energy, and another is pressure head. Velocity head is the simplest of all. Just close your eyes and all points write 0. Close your eyes and write 0. Write 0. Why? Because in soil mechanics, if water is rest, so velocity head will be 0, v square by 2g. Velocity head is v square by 2g. If you see the units of v square by 2g, again it will be meter. So velocity head will be 0. If water is at rest, it will be 0. Kinetic energy will be 0 of rest points. of rest points, kinetic energy is 0. Even if the water is moving very fast, even if the water is moving in soil, even if the water is moving in soil, if the water is moving in soil, the speed of water is not like Usain Bolt. The speed of water is not like Usain Bolt. The permeability of sand, 10 to the power minus 5 meter per second. Clay, 10 to the power minus 7 meter per second. 10 to the power minus 8 meter per second. Even if the water is moving in soil, the speed of water is very, very, very less. So velocity head will be 0. So if it is rest, you have to take 0. Even if it is moving, still velocity head will be 0. So velocity head is the easiest of all. In all cases, in all soil mechanics problem, whether whatever the case is, upward seepage, downward seepage, no seepage, rest condition, not rest condition, right movement, left movement, downward movement, upward movement, always it will be 0. Now datum head. Datum head is simple. The height above the datum. So 2, 3, 4, 5. 2, 3, 4, 5. 2, 3, 4, 5. All are at datum only. 2, 3, 4, 5. All are at datum only. 2, 3, 4, 5. All are at datum only. So it will be 0, 0, 0, 0. 2, 3, 4, 5 will be at datum only. So it will be 0, 0, 0, 0, 0. Okay. Now 1 point 2, 3, 4, 5 height from datum is 0 because it is at datum. 1 point how much height? H1 height from datum. And 6 point how much height? H2 height from datum. So it is also easy. It is also easy. Okay. 1 and 6 will be having height H1 and H2. Now pressure head. Guys, if I am not considering the atmospheric pressure, at 1 point there is no pressure, 0. It is open to atmosphere. No water pressure. Atmospheric pressure I am not considering. 6 point also 0. What is the pressure at 2 point? How much water? H1, what is the pressure at H1 point? Gamma H1. So we have to write only head, na? So at, 2 point. 2 point, what is the pressure? Gamma H1. So we will write only height, that is H1. At 3 point, 2 and 3 are at same level. 2 and 3 are at same level. So again the pressure will be same, it will be H1. 6.0 pressure, but 5 point, what is the pressure? Gamma H2. Gamma H2. So it will be H2. It will be H2. 4 and 5 are at same level. 4 and 5 are at same level. So pressure is H2. Now my question, before I tell you what is quicksand condition, before I tell you what is quicksand condition, I want to ask you that I told you 2 and 3 are at same level. So same pressure H1, H1. 4 and 5 at same level. So same pressure H2, H2. Guys, then 3 and 4 are also at same level. Then why not same pressure? 2 and 4 are also at same level. Why not same pressure? 3 and 5 are also at same level. 3 and 5 are also at same level. Why not same pressure? Guys, write a note in your notes. Write a note in your notes. Pressure is same. Pressure is same at same level. At same level. It is wrong statement that you know that pressure is almost always same. Whatever you are studying now, that pressure is always same. This is the wrong thing you are studying. This is the wrong thing you are studying. That pressure is same at same level. This is, I cannot say wrong, but I can say this is incomplete information. Pressure at a same level in water is same. It is wrong. It is incomplete statement. It is incomplete statement that pressure at same level is same. No, the complete statement is pressure at water in same level is same. Pressure in same is same at same level only when we can move between those 2 points. Between those 2 points. We can move between those 2 points in same medium. If, see what I want to say, 2 and 3 you can move from water to water. So same pressure, H1, 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 H1. 4 and 5 you can move from water to water. Same pressure H2. But from 2 to 4 you cannot move through same medium. Here water will be coming, then soil will be coming. Okay, so water to water same pressure. Only when between those 2 points you can go from water to water. Another medium is not coming. Here another medium is coming, so pressure will not be same. Everyone give me yes or no? Everyone give me yes or no? Have you understood what I want to say? So pressure is same level in water if you go between those 2 points from water to water. If there is some connection of pipe na, and in that pipe only it is water. If there is some connection of pipe like this, and in that pipe there is water, then from 2 to 4 you can go from water to water, 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 water. Then same pressure. Then same pressure. Okay? Understood, sir? Now the total energy. So total energy is 0 plus 0 plus H1 is H1 here, 0 plus H1, this is H1 here, this is H1 here, this is H2 here, this is H2 here, this is H2 here. So H1, 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 H2, H2, H2. That means 1, 2, 3 is same energy. That means if I draw that say energy line, so 1, 2, 3 same energy, H1, 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 4, 5, 6 same energy, H2, 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 this is the height H2, and between soil there will be loss. This is total energy line. This is total energy line. In water to water, guys, always in soil there is no loss. In water to water there is no loss, constant energy. Water to water there is no loss, constant energy. All loss occurs in soil only. Why? Because in water, suppose I am considering this point, as you are going down, velocity head will be 0 now. In these 3 matches, one match will always be tie, 0, 0, 0, 0 for all points. As we are going down now, pressure will increase. For bottom point, pressure will be more, and for top point, datum head will be more by same magnitude. So total energy will be same. As we are going downward, velocity head will not be changing, it is 0. As we are going downward, pressure will be increasing for below points, but datum will be decreasing by same amount. So total energy will be same in water to water. Everyone got it? Got it? Okay. So that is the energy, H1, H1, all energy losses here. Now guys, this is hydraulic gradient I. It is head loss per unit length. If the length of the soil is L, head loss is energy loss. That is H1 minus H2, H1 minus H2 by L, that is hydraulic gradient. Still guys, I have nothing mentioned about the quicksand condition. Still I have nothing mentioned about the quicksand condition. I am making your base, guys. Everyone derives like quicksand condition like anything. I will be touching from the basic level. Now at 3 point, total head at 3 is greater than total head at 4. And energy at 3 is H1, energy at 4 is H2. So that means water will flow. That means water will flow. That means water will flow. Water will flow because everything in this universe wants to go from high head to low head. Everything in this universe wants to go from high energy to low energy, because at low energy the things are more stable. Okay, the things are more stable, so it will go from here to here, it will go from here to here. Okay sir, that is called seepage. If we relate this movement with volume of water, that is seepage. If we relate this movement through speed, that is permeability. This movement, if I am showing in terms of discharge, that is seepage. If this movement I denote with respect to velocity, that will be permeability. That is, permeability will be relating the velocity, and this seepage will be related to discharge. Okay. Now when this water is moving, it will be having some pressure now. When this water is moving, it will be having some pressure now. That is called seepage pressure. It is majorly due to frictional drag. When this water is moving, this will be creating some pressure. That is called seepage pressure. So seepage pressure also called as PS, is equal to HL into gamma W, or HL if I represent with H, it will be H into gamma W. So seepage pressure, okay, is given by H into gamma W. Okay. Now this is seepage pressure. If I denote seepage force Fs It is seepage pressure into area. H gamma W into area of this soil skeleton. It is area of soil skeleton. Okay, sir. If I denote seepage force, very important. From here the questions are asked in various competition exam. Seepage force per unit volume. Seepage force is represented by small fs. It is H gamma W A upon volume. Volume is A into L. Area into length. Area into length. A to A cancel. H upon L is I. So seepage force per unit volume is head loss per unit length. HL by L is I. It is I into gamma W. So seepage force per unit volume is I into gamma W. Seepage force per unit volume is I into gamma W. Okay, sir. Got it, sir. Sir, still you don't tell anything about this person. Still you don't tell anything about quicksand condition, sir. You are telling all these things. You are telling all these things, but you didn't tell. But you didn't tell about the quicksand condition. Tell me, sir. Tell me, sir. Understood or not? Till here any doubt? Till here any doubt? No doubt. Okay, sir. Okay. So this is seepage force per unit volume is I into gamma W. Now quicksand condition, directly it is going to question. Okay, let me give a new let me give, okay, here copy, paste, okay. So seepage force per unit volume you understood. Now guys, see, effective stress guys, suppose this is ground level, this is dry soil, gamma D, this is H. So what is effective stress at B point? Effective stress at B point is gamma D into H, because U is 0. U is 0. If guys now water table also comes here, this becomes now not dry. This is now gamma sat. This is gamma sat. So what is effective stress B? Gamma sat H minus gamma WH. Total stress minus pore water pressure, it is gamma submerged H. This is when no water. So this is old. I am saying this as old effective stress. Old effective stress. Old means, what does old means? Old means in hydrostatic case. Old means hydrostatic case. When water is at static case, when water is static case, then only you, how you have calculated this? You have calculated this gamma total stress sigma minus U gamma WH. When it is hydrostatic pressure na, when it is hydrostatic pressure na, when it is hydrostatic pressure na, then only you can write down, then only you can write down as water pressure as gamma WH. Then only you can write down water pressure as gamma WH. Yes or no? Yes or no? Give me. Guys, when it is no movement of water, when it is no movement of water, then only you then only you can write down, then only you can write down as gamma WH. Water pressure is gamma WH when it is hydrostatic pressure. Guys, see, let me give you example. When it is hydrostatic na, then only you can write gamma WH at H height. When it is moving at H height below, when it is going like this, when it is going like this, when it is going like this, then you cannot write pressure as gamma WH. Then you cannot write pressure as gamma WH. Then you cannot write pressure as gamma WH. Okay, so this is old. Old means not in terms of time. Old means before we in geotechnical we come up to the seepage chapter na, quicksand chapter na, before that we have written effective stress like this only. Before that we write effective stress like this only. Old means not in terms of time. Old means when I teach this, the correct sequence of studying the soil mechanics, before this I have taught all these things. So up to now the student is assuming only this. This is the effective stress, this is the effective stress, this is the water pressure. But this water pressure is only in static case. Means when there is a soil mass, okay, it is completely saturated, and now there is upward seepage or downward seepage, then you cannot write pressure as gamma WH. So then effective stress will not be simple like that, because you don't know U na, sigma bar is sigma minus U na, you don't know what is pore water pressure, what is U, U means pore water pressure. In that case, you write sigma bar net at any point. Suppose this H point, H height below, sigma bar net is sigma bar old plus minus HL into gamma W. Old means it is hydrostatic case. What will be the effective stress for hydrostatic case? What will be the effective stress for hydrostatic case? Okay, what will be the effective stress for hydrostatic case? That is sigma bar old. What will be the effective stress for hydrostatic case? That is sigma bar old. Okay, and plus for upward seepage, plus formula for downward seepage, and minus for upward seepage. Why, sir, plus for upward? Why minus for downward? Everything will be cleared in next 300 seconds or even before that. Guys, first of all, sir, is that formula not valid? Sigma bar is sigma minus U. Is that not valid? Yes, this is also valid. Yes, this is also valid. Okay, this is also valid. But here, if you apply this formula, then you should be writing, you should write actual U, which may be not gamma WH. Pore water pressure can be something else. In case of seepage, the pore water pressure can be something else, not gamma WH. Actually, it is U is equal to gamma W into pressure head. You have to calculate pressure head there. Like you have to calculate pressure head. Okay. In hydrostatic case, pressure head is also the water height. Pressure head is also water. Gamma WH, water height is pressure head. But in case of seepage, the pressure head can be something else other than pressure height, other than height of water. So this is, so you don't say, sir, up to now we are studying this formula, now we are studying this one. This is also correct. You can apply sigma minus U. Effective stress is total stress minus U is still correct. It is always correct. But U, the pore water pressure, the pore water pressure, you have to find the correct one, not the hydrostatic one. If the case is not hydrostatic, how you will be writing the pore water pressure as hydrostatic pressure? If the hydrostatic condition is not there, it is seepage condition. It will be something else. So either you write this, I have done many formulas. The same question I am solving from this also, for this also. So that students is not confused. So I calculate the questions from this also in seepage case. Next question. Sir, why plus for downward, why minus for upward? Very easy. Very easy. Suppose this is Abhinav Negi or any person. This is floor. What is effective stress? What is effective stress? Effective stress is the contact force between particles. Effective stress is the contact force between particles, correct or not? Effective stress is the contact force between particles, na? Give me yes or no. Effective stress is the contact force between particles, na? Okay, so when there is downward seepage, in that case, when there is downward seepage, then contact force will increase or decrease? When there is downward seepage, contact force will increase or decrease? See, this downward seepage. Somebody is pushing me like this, like this, like this, like this. So contact of my foot and floor is increasing, na? Somebody is putting like this, somebody is putting like this. So contact force between my foot and floor is increasing, na? Somebody is putting like this, contact force is increasing, na? and somebody is pulling me like this, somebody is pulling me like this, somebody is pulling, contact force is decreasing na, somebody is pulling, so contact force is decreasing na, contact force is effective stress. So when it is downward seepage, the attraction between the particle increases. When it is upward seepage, attraction decreases. When it is downward seepage, attraction increases, plus. When it is upward seepage, it is minus. It is minus. Okay. Okay. Okay, sir. Now, guys, plus is very good. Plus is very good. Minus is the case where, oh my God. Plus is effective stress increasing. Na? Effective stress increasing means more shear strength. If there is more contact force between particles, if there is more contact force between particles, they will not go here and there. They are tightly in contact. Less chances of landslide failure. Less shear strength, less contact force between particles, it will shear off. Anybody, any force can shear off them. So minus will be a case of worry. Minus will be a case of worry. Okay, now quicksand condition means when this sigma bar net is 0, it will be only in upward seepage, because upward seepage it is minus na, downward seepage yaar, how it will be 0 yaar, it is something here, a positive value, it is plus, how it can be 0? So only in upward seepage it can be 0. That condition is called quicksand condition, is called quicksand condition, or it is called as piping condition, piping condition, quicksand condition, or it is called as floating condition, or it is called as bursting condition, or it is called as neutral condition. When sigma bar net is 0. How to write sigma bar net in upward seepage? Sigma bar net is 0. How to write this? It is gamma old. So at any z height below, suppose it is z height, not at it is, let it be h height. So what is old? Gamma submerged into h. For upward case it is minus HL into gamma W. Let HL be h, head loss, gamma W is equal to 0. What is gamma submerged formula? What is gamma submerged formula? Tell me G minus 1 upon 1 plus E into gamma W into H minus what is H? Head loss. What is, guys, I is HL by L na? I is HL by L. So length is here H. Water movement is in H. Water movement is H. When it is going upward, the water movement is H. Okay, so I is this. So what is HL? I into H. What is HL? This is HL na? HL, pressure is HL into gamma W. HL into gamma W. So what is HL? I into H into gamma W is equal to 0. And this I is not ordinary I. This is called IC, because this is at this IC when it is becoming 0. And what is IC? It is called piping gradient, it is called floating gradient, it is called bursting gradient, or critical gradient, or neutral gradient. IC is critical gradient, bursting gradient, piping gradient, neutral gradient. Neutral gradient. Okay, this is the IC when effective stress is becoming 0. So H gamma W will cancel. From here, this is the gradient at which effective stress conditions will be derived, will be arrived. So at critical gradient G minus 1 plus E, we will be getting effective stress 0. Guys, many of students still know till here, but what is E? E is N upon 1 plus N. If you simplify this, IC critical gradient is this. If you simplify this, E is equal to N upon 1 minus N. E is equal to N upon 1 minus N. If you solve this, it will be G minus 1 into 1 minus N. This is the critical gradient, and this critical gradient will be near about 1. Why? Guys, if you are solving the question, it is not coming 0.8, 0.9, 1, 1.1, 1.2, not coming around 1, 0.8, 0.9, 1, 1.1, 1.1, 1.2. That means you are wrong. Why? Because G is value is around 2.6 to 2.7 minus 1. That is around 1.6 to 1.7 upon 1 plus E. E value is again 0.6 to 0.7%. E value is also again 0.6 to 0.7. So numerator also 1.6 to 1.7, something like this. Denominator also 1.6 to 1.7. So IC value has to become 1. And factor of safety is IC by I. If your I is lesser than IC, if your I is lesser, then this minus value will be lesser, na? So more positive value will be coming, more effective stress, that is good. Okay, so this is the factor of safety. Why it is quicksand? Why not quick clay? Can anyone tell me? Why not quick clay? Why not quick clay? Why quicksand condition? Why not quick clay, guys? Because guys, it is not quick clay. Because even if effective stress 0 in clay, still there is some strength. Still there is some strength due to cohesion. Due to cohesion, there is still some strength. Even if there is no attraction, no contact force, still there is some bonding because of cohesion. Okay, so if this is a dam, okay, water level is here, it is this much, here it is less, so water goes from high head to low head. So here it is good, downward seepage it is good, effective stress will increase, but at the time of exit, this is a worry. Here we may have a quicksand condition, because upward seepage there is quicksand condition, downward seepage is good. So hydraulic gradient at exit should be less than critical gradient for safety. If it becomes IC or greater than IC, there will be a quicksand failure. Have you understood the concept? Everyone? Now you can solve any questions. Okay, so these are the questions that I will give you an assignment. Okay, let us do a couple of questions. First of all, do this. The hydraulic gradient IC is G minus 1 plus E. Okay, so what is G? Specific grade 2.62 minus 1. What is E? 0.62. So IC is equal to 1. Okay, this one, factor of safety they are asking. Factor of safety is equal to IC by I. Okay, what is IC? Critical gradient G minus 1 plus E. So 2.65 minus 1 plus E. Where is the void ratio? Void ratio 0.65. So IC is equal to 1. Now what is I? I is HL by L. What is head loss? 4 meter thick under total head difference of 2. Head difference 2 and water, this is the length. So it is 0.5. So it is 1 divided 0.5. So factor of safety is equal to 2. Okay. This is how other questions I am giving you in the homework. So guys, again I am telling you the very 2 big days, Saturday and Sunday, 7 September and 8 September. If you want to enroll in Resultant on all our upcoming courses, you will be getting up to 90% discount. First to third rank 90% discount, then 80, then 60, then 50. What you have to do, links we have given in the Telegram group. Links are in the description box. And guys, with these links, or you can download the Resultant Civil app from the Play Store. You can download the Resultant Civil app from the Play Store. From all those apps from the Play Store, you can download the app from the Play Store, Resultant Civil, and then you can give the scholarship test. This test is free of cost, only on Saturday and Sunday, today and tomorrow. Just give this test, 20 questions of 45 minutes, SOM, FM, mathematics, aptitude, 5 of SOM, 5 of FM, 5 of mathematics, 5 of aptitude. And if you get ranked, you will be getting the discounts on all our upcoming courses. And tomorrow 8 p.m. the new faculty will be adding to Resultant team to help you. Okay, these is the numbers where you can join us. Okay, thank you guys. I hope you enjoyed the session. Thank you all.